Okay, hey guys, my topic is rate of motion and change. So today we'll be talking about the rate of motion and change in terms of geology. So first, the goal of this lesson is to learn how to calculate the rate of change for specifically in this class, erosion and tectonic plate movement, but how you calculate that can also be used for many different things. So here's the equation for the rate of movement, which is just distance over time. And in this case, it's usually meters over years since we were talking about kind of like long geologic time periods and um, large measurements such as like big rocks, mountains, stuff like that. But this equation can be used for many different things and you can play with the units and everything. Okay, for context, like I said, this formula can be used for pretty much anything changing over time. I'm sure you guys have heard of the rate of change formula in different math classes and stuff. So it's pretty much the same type of thing. It could indicate change in erosion, growth, weather, temperature, and so many more things about planet Earth, and also just so many more things that you use in your day-to-day life, or how long, or like how tall are you growing over how many years and stuff like that. But in this lesson, we'll be using the formula to find not only the rate of change of a specific characteristic of Earth, but also scaling that to in a way that makes sense to us and geologically. So in class, I'm sure you guys remember talking about 1 meter, but in geology context, this means that like things on Earth are so large that geologists classify them in certain categories rather than actually measuring them exactly. For example, we talked about how like 1 meter could be the length of a desk or something, but that's not actually 1 meter. We just categorize things around that size in 1 meter in order to compare it to other things that are in other categories, such as 10 meters or 100 meters. So just remember that as we're going through this today. So, kind of similar to what we did in class, let's take some real life application upon the 1 meter geological scale. And so, if you think about life on campus here, we can scale things in the dorms to how geologists would. So, I just have a couple examples here, and feel free to think about other examples around you and in your dorm and on campus that can also be similar. So for 1 meter, my example I thought of was a lined piece of paper. Now this is not exactly 1 meter, but 1 meter, or like for instance, the piece of lined paper is less than the 10 meters dorm closet. So again, the dorm closet might not also be 10 meters, but yes, it's bigger than the lined piece of paper. And then moving on, it is smaller than one singular dorm room, which is 100 meters under that category. And then for the 1,000 meters category, I just put the whole Yakatutu community. Now, this may not be exactly the right measurements to scale and proportion. It is geologically correct. And as we did in class, how we wrote down some ideas, it doesn't have to be exact. Everyone had different answers for each category, but as long as it's smaller than the next category or bigger than the one behind it, then it should fit how geologists would measure certain things. So now we have a couple practice problems. So the prompt, you feel free to pause and solve the questions on your own and come back for the answers, or we'll work through them together right now. So for prompt one, a tree is 1 meter at 5 years old. For the first question, it asks, how many meters per year has this tree grown? So this is something that we'll have to go back to and use the rate of change formula with because it's asking how many meters, which is the distance over time, which is years, this tree has grown. So for this one, you would do 1 meter, or the rate of change equals 1 meter over 5 years old. So 1 divided by 5, you get the answer of 0.2 as shown right there. So 0.2 meters per year is how much this tree has grown. So now the second question isn't really a rate of change question, but it follows along in the same context, and I'm sure on tests there might be questions similar. It asks how many centimeters per year does this tree grow? So you have to convert 0.2 meters into centimeters, By doing this, you do 0.2 times 10 and you get 20 centimeters. So this conversion isn't something that is technically a part of rate of change, but it is something that you should know because oftentimes you'll be asked to scale things differently for certain answers. Okay, prompt two. A mountain loses 50 centimeters of height over 5,000 years. So this is a sort of erosion question. So we're trying to find the rate of erosion in centimeters per year. So that's question one. So for this one, you would do, again, the distance over time. So 50 centimeters over 5,000 years, which is equal to 0.01 centimeter per year. So your rate of erosion for this mountain is 0.01 centimeters per year. For the second question here, how much erosion in centimeters would occur over 200 years? So again, this isn't a rate of change question, but maybe a sort of practice problem that would follow along this rate of change idea. So for this one, you would do, excuse me, 200 times 0.01, and then you would get 2 centimeters. So in 200 years, the mountain would erode 2 centimeters. Okay, so that was the rate of change formula. I hope you guys have a better understanding of how the formula works and what type of questions you will see that go along with it. Thank you.